momentum, it will guide us into what we call collision. Okay?
Yes, sir.
So the law states that, right? The law states that. The law states that. Are you there?
Yes, sir.
In a system of colliding bodies. In a system of colliding bodies. In a system of colliding bodies. Okay?
Yes, sir.
The total momentum remains constant. The total momentum remains constant. Are you there?
Yes, sir.
Provided no external force acts on the system. Provided no external force acts on the system. Provided no external force acts on the system.
Yes.
Okay? So mathematically, it simply means that sum of momentum is what? It's constant. Okay? And this force, no force is applied. Force is zero. So right there.
Yes, sir. Yes, sir.
Full stop. Also right, the law also states that in a system of colliding bodies, also says that in a system of colliding bodies, okay,
Yes, sir.
the total momentum before collision, the total momentum before collision
Yes, sir.
is equal to the total momentum after collision. Is equal to the total momentum after collision, provided no external force acts on it. Provided no external force acts on it.
Yes, sir.
So what does the theorem mean now? The theorem is trying to tell us
So
that
check it.
total momentum before, this is how you write before collision, okay, is equals to total momentum after, this is how you write after collision. Okay, that's what the law is trying to tell us.
Yes, sir.
So with that, so we have been hearing the word collision. Let's discuss what collision is. Collision. Okay, are you done?
Yes, sir.
So, right, collision occurs when two or more bodies
Yes, sir.
exert relatively strong force on each other, over a short period of time.
Relatively.
Strong force, relatively strong force on each other. Over a short period of time.
Yes, sir.
That's what collision is all about. So let's discuss types of collision. Types of collision. Okay.
Yes, sir.
Right. There are two types of collision. One, we have elastic collision. Elastic collision.
Yes, sir.
Elastic collision is a type of collision in which both the linear momentum and the kinetic energy is conserved. Both the linear momentum and the kinetic energy is conserved. Both the linear momentum and the kinetic energy is conserved.
Yes, sir.
Okay. So what do you mean? What do they mean when they say something is conserved? When they say conserve something, what does it mean?
Right. The linear momentum and the kinetic energy is like on the same pace or something.
No. For something to be conserved means nothing is lost. Everything is perfect. No, you didn't lose anything. Everything is conserved. Okay, everything is saved or safe. Nothing is lost. Do you understand? That is
Yes,
what
sir.
you need to conserve. I mean, the linear momentum is safe. It's completely safe. Kinetic energy is what is safe. According to the law of conservation of linear momentum, according to law of conservation of linear momentum, right? It said momentum before collision, cause momentum after what?
After collision.
Collision. So what happens if we are dealing with elastic collision? Now, if we want to cause elastic collision, let's assume this is a ball, okay? And this is another ball of different masses, okay? Let's call this one M1, let's call this one M2. Okay, this is before the ball collide. The balls can be traveling in opposite direction, or you can travel in the same what?
Okay.
In the same direction. That means this one will hit this one. If you are traveling in the same direction, the M1 will hit the M2, right?
Yeah.
If you are traveling in opposite direction, they will hit each other.
Each other.
Is that not? So this is before they collide there. So let's assume this one is traveling with velocity U1, this is traveling with velocity U2. Or this is traveling with velocity U1 and velocity U2. So in this case now, it means that U1 must be greater than U2.
U2.
Is it not?
Yes, sir.
Greater than U2. So, well, this is
Oh.
before collision, before they collided.
Is it in the one that they are going in the same direction? That U1 will be greater than U2? Or
Yes,
both of them?
yes. No, why they are going in the direction, U1 must be greater than
Okay.
U2. Because let's assume a vehicle is moving and another vehicle is at the back. For the vehicle at the back to hit the vehicle at the front, that means it's traveling at a higher speed than the
Yeah.
vehicle at the front. So that's why U1 must be greater than U2. So what happened after they collide? After they collide, there are two possible scenarios. The two bodies can, when they collide, they can stick together or they can move apart.
Yeah.
In the same direction or in opposite direction, right?
Yes.
This is before they collided. So let's find a scenario whereby the two bodies collide and move in the direction of the first ball. Okay? This remain my M1, this remain my what? M2. So when they collide, that means there's no way the speed they used to collide, it will be different for the speed they collided, right?
Yeah.
And it cannot be the same speed anymore. Let's call this one V1 and what? And V2. This is when they collided and travel in the same direction. Is that not?
Yes.
So what's not the momentum? What is not the momentum of this ball? Momentum of this ball will be what? Momentum is mass times what? Velocity, right?
Velocity, yeah.
And the momentum of the first ball will be what? M1,
M1,
U1.
U1.
Abi? So
Yeah.
remember, it says in a system of colliding bodies, the total momentum before collision. So let's get the total momentum first before collision. So for the first ball, we're going to have M1, U1, plus second ball will be what? M2, U2. Is equals to first ball after collision, M1, V1, plus M2, V2. Okay?
Yes.
So what happened? This is in the same direction, in the same direction. So what happened if they are traveling in opposite direction? So what are we going to have? They are traveling in opposite direction. That means I'm considering this one now and this, right?
Yes.
Then when they hit, okay, let's assume this way. So according to sign convention, when you have arrow like this is plus, minus, this is what? Plus, this is what? Minus. According to sign convention, right?
Yes.
So let's assume the two balls now are traveling in opposite direction. So what will be the momentum of the first ball? It will also give us what? M1, U1. Second one will be minus M2, U2. Agree?
Yes.
Because it's traveling in opposite direction to the first one. For that reason, it becomes a negative value.
Yes.
Then it's equals to the same way, the two hits, M1, V1 plus M2, V2. Okay? This is in opposite direction. Is that clear?
Yes.
In opposite direction. So you have to follow the statement clearly. So in this case now, this is all what I've done now is elastic. All these are elastic collision. So what happened? We have seen that the linear momentum is what is conserved. Abi, what about the kinetic energy? So let's deal with the kinetic. So what will be the kinetic energy of this ball? Will be what? 1 over 2 M1 U square 1. Second ball will be what? 1 over 2 M2 U square 2. This is before, right? After we 1 over 2 M1 V square 1 plus 1 over 2 M2 V square 2. You see, nothing is lost. Total momentum before collision, the kinetic energy before collision equals the kinetic energy after collision. Yes, so write all this on before we make progress.
I'm done. I'm done. I'm done.
Okay, so let's go to inelastic collision. Inelastic collision is the second type of collision that we have. Inelastic collision. Are you there?
Yes, sir.
Right, it's a type of collision. It's a type of collision in which the linear momentum is conserved, but the kinetic energy is not conserved. Linear momentum is conserved, but the kinetic energy is not conserved. Okay. Hello?
Yes, sir.
Okay. So let me describe a scenario for you. Let's assume you have a very big truck. A very big truck. And a small car. Okay.
Yes, sir.
So this truck has a mass, let's call it M1, a moving with velocity U1. Let's call it this M have a mass M2, moving with velocity U2. So for instance, let's assume our U1 is greater than U2, for instance. Okay?
Yeah.
That means the big truck will catch up with the small vehicle in terms of speed. You're going to catch up with it, right?
Yes, sir.
What happens if you catch up with it and you make an impact with this small vehicle?
It's move forward.
It's moving forward with what speed? Is it with the speed of the small vehicle or moving with the speed of the bigger vehicle? If
The
the,
one
if the,
of the big vehicle.
if you hit the small vehicle and the two bodies stick together, maybe I believe must have seen that when vehicle hit, they stick together. That we have seen a situation like that. Abi? When they
Yeah.
hit and they stick together. So when they stick together, is it moving with the speed or they will move with a certain speed, right?
Yeah.
So which speed are they moving with? Is it the speed of the small vehicle, speed of the bigger vehicle?
The speed of the bigger one.
Yes. That means small vehicle has lost what? What has small vehicle lost?
Velocity.
Exactly. So at the end of the day, if the two body hits and they stick together, are going to have, let's assume this is the truck now. This is the, well, assume this is not the truck. Here is small vehicle. Here is M1, M2. They will move with a common what? Common velocity. So
Yes.
they can no longer move with V1 and V2 because they stick together. Are you getting it? Are you there?
Yes, sir.
So let's follow the principle of conservation of linear momentum now. That's the momentum before collision, because momentum, sum of momentum before collision is equals to sum of momentum after collision. So before collision will be what? M1
M1,
U1
U1.
plus M2 U2.
U2.
After collision, what are we having? M1V plus
M1V plus
M2V. So both of them will move with a common velocity, V. Abi, which is a velocity of V1, sitting at velocity of V2. Let's call the three of them as what? Two of them as a V.
V.
So I'm having M1 U1 plus M2 U2 equals to V is common, having M1 plus M2 bracket V. I factorize that V. Okay?
Yes, sir.
So what about the terms of kinetic energy? Kinetic energy of the first vehicle will be what? 1 over 2
M1
M1 U square
U
1
square
plus 1 over
plus
2 M2 U
M2 U
square
square
2
P.
plus equals to 1 over 2 M1 square 1 over 2 M2 V squared. We can also be written as what? 1 over 2 into M1 plus M2 bracket what? V squared. Because V squared is common, and 1 over 2 is also common. Right?
Yes, sir.
So this is the concept of inelastic solution. So write what we have.
I'm done.
If you are true, let me know.
Okay. I'm done.
Okay. So this is the concept of collision and types of collision. Okay.
Yes, sir.
Okay, let's take examples. Okay, so let's see how we can make progress from here. Okay, example 1 said 2 lorries of masses 50 kilogram and 52 kilogram traveling on the same rates, traveling at the same rates, traveling at the same rate. With speed 6 meters per second and 4 meters per second, respectively, in the same direction.
Just need to be short. In the end, is defeated. Leave down over. Just do it.
In the same direction. If there was a collision, if there was a collision,
Yes.
and the two hook with what speed they move? Hook with what speed? With what speed do they move to 1 dp?
Yes.
So are you set?
Yes.
Okay, so first of all, what type of collision is this? What kind of collision do we have in the question?
Inelastic.
Yeah, because the two bodies hooked together, right?
Yeah.
So for that reason, it's an inelastic collision, isn't it?
Yes.
It's an inelastic collision. So you must do well to identify the kind of collision that is involved. Okay? You should identify it before you start solving it. So we know it's an inelastic. So let's see now. That answer, this is the first lorry. And this is the second lorry. What's the mass of the first lorry? 50 and 52. So 50 kilogram, 2 kilogram. So this one moved by 6 meters per second. Why this one moved by 4 meters per second? So what happened? The two lorries hooked together. So here remain as what? 50 kilogram. Here remain as 62 kilogram. And they move with a common velocity. So as you know, momentum before collision equals momentum after collision. So I'm going to have M1 U1 plus M2U2 equals to M1 plus M2 bracket V. Agree? Because
Yes,
V1,
sir.
V1 is V2, both of them is V. So, so if I make the solid formula, what am I having? We're going to have M1 U1 plus M2 U2 over M1 plus M2. Right?
Yes, sir.
So let's put in the values now. What are we having for substitute values? I'm going to have 50 times 6 plus 62 times 4 over 50 plus 62. So 50 times 6 will give us what? 300
300.
plus 62 times 4 is 248. 248 divided by what? 50 plus 62,
50
that's
plus 62.
1112. So if you add it all, what will you have?
4.89.
No, add it up first.
Oh. 548.
548 divide 112. So you have a 4 point what?
4.89.
4.89 meter per second. That is not
They
the
said
correct
to
number.
1 dp.
Okay, to 1 dp now, that is
4.9.
4.9 meter per second.
Yes, sir.
Mhm.
So when do we know when to use the first formula?
And when you have to use the first formula if the body did not stick together now.
Okay, when it goes.
When they don't stick together and they travel in the same or in opposite direction after collision. So that's why you know you have to use the common number. What the most important thing is that the two bodies must not stick together.
Okay.
That's what is important.
So the one that sticks together is the inelastic, while the one that does not stick together is the elastic.
Yes.
I'm done. I'm done.
Okay, give me 1 minute.
Yeah, you're meant to answer that question. We don't have to continue. Don't continue.
Let's take another example and see. Let me look for a question to use.
Don't worry, they will compensate you. So you just pick it up to them. Most of them are able to answer. They are not tough questions. They are it's what you what they train you for. It's what they taught you. You're not going to ask a question from the book that you have not read. That's why they certify the books and 4 books. The questions we ask are 4 books. The quotations from those same studying passages from those same from those same papers. But that's why they're telling you read those papers and become everything. So that any year they want to read the person, any year they want to read the person, you can just say what's substituting from the book inside you. What's this verse from mathematics? Because you are reading it, because you are reading it, maybe. So that's why you have to read it. Get used to all those repetitions, get used to every verses. The only question you pick is that I believe that to be able to escape. It's not a person. I got all my voice very high. You need to be able to listen. You are very person. So you just want to. Most of you can understand this in a minute. No mistake. Yes, please. So,
Textbook, is it close to you?
Sir?
Your textbook, is it close to you?
Yes, sir.
Bring it, let's see if we can see some question from there.
I've seen some question.
Okay, read it, let me see.
A 30 kg shell is flying at 48 meters per second
Wait,
when
a
it
30,
explodes.
a 30 kg share is flying
Yeah.
at what?
48 meters per second.
And then it explodes, okay?
It's one part of 18 kg stops.
I didn't hear you. One part.
It's one part of 18 kg stops.
It's one part of 18 kg. Stop.
Yes, stop.
Okay.
While the remaining flies on.
While the remaining flies off.
What is the velocity of the later?
What is the velocity of the later? What is the velocity of the later? What is it?
Yes, sir.
Okay. So the mass of the shell is 30 kilogram, right?
Yes, sir.
And
No,
it explodes.
48. Yeah.
The mass is what?
30.
Okay. And it explodes, right?
Yes, sir.
So let's say this is the shell now. Mass is 30 kilogram. It explodes into how many parts? There's one here. There's one here.
Yeah.
So it said one part of the 18 kilograms stop. So this, let's say this is the first part. Let's call here is 18 kilogram. Okay. So this part
Yeah.
now, we don't know the mass here, but the shell was moving at what? 48 meter per second. This one stopped, and this one continue what? Flying
Wow.
up. Is it not?
Yeah.
And we are asked to find the velocity, right?
Yeah.
So what would be the mass? The total mass of the body is what? Is
18 kg plus
30 equals to 18 plus m.
plus 5.
Agree?
Yes, sir.
So what is our m? Our m will give us what? 30 minus 18. M will give us 12
So,
kilograms. So the mass here is 12 kilograms. Right?
yes.
So since this one stopped, what will be the velocity here?
Yeah.
Is 0. So we are going to have total momentum equals to momentum of, okay, let me say momentum of share equals to sum of momentum, right? Sum of the two other momentum. What is the magnitude of the share? It's not 30 times what? Times 48.
40.
The first mass, 18 times 0, because it says stop. So the second one is not 12 times V. Is it not?
Yes,
So,
sir.
yeah, what is 30 times 48? What are we having?
That is 1,440.
It's equals to 0 plus what? 12V. That
12V.
was 12V. Therefore, my
Yeah.
V is 1440 divided by what? What are we having?
120
120 kilogram, 120 meter per second.
plus 40.
Understood?
Yes, sir.
Okay.
I'm done. I'm done.
Okay. Is there another one there?
Yes, there's one thing.
Okay, let me see it.
A body of mass 10 kg.
A body of mass 10 kilogram.
Moving with velocity 10 meters per second.
Moving with velocity and per second. Okay.
Hits a stationary body.
It's stationary body
Of mass 25 kg.
of mass 25 kilograms.
And has its direction reversed.
Its direction reverse. Okay.
And its velocity is changed.
And it's what? Velocity.
Velocity
Yes, it's what?
is changed
It's changed. Okay.
to 7.5 meters per second.
To 0.5 meter per second.
In 5 seconds.
In 5 seconds.
Calculate A.
Calculate A.
The velocity of the later body.
Velocity of the latter body. Okay.
The magnitude of the force of impact.
The magnitude of the force of impact.
That's all.
Okay. So we have a question. You say body of mass 10 kilogram moving with a velocity of 10 meters per second is the stationary body of mass 25 kilogram. So let's draw that. Let us this is the body. Mass is what 10 kilogram moving with 10 meters per second. You say it hit the stationary body. Mass is 25 kilogram. Body is not moving, so the velocity here is what?
0.
Is 0. So you said has the direction reverse, and the velocity changes to what? To
7.5.
meter per second in 5 seconds. So after what happened after the impact? Okay. There is not 10 kilogram, right?
Yes.
I say direction is now what? Reverse. You see it?
Yeah.
Second body is 25 what? Kilogram. They tell us that let's say this is V.
Yeah.
So what is the momentum of this first body? It will be 10 times what? 10. It will be 25 times what? 0.
0.
It will be 10 times 7.5 minus 10 times 7.5 plus 25 V.
Yes.
So here will give us what? 100 plus
Yes.
0 also minus 75 plus 25 what? V.
Yes,
Is it-
sir.
Check the answer. Is the answer 1?
Sir?
What's the answer? Is it 1 meter per second? Check first. Let me say and has return body of mass and has direction reverse. So this also 25 seconds.
This 75, is it not minus 75?
Yeah, I'm asking, what's the answer? Is it 1? Because the question is, like, I'm perceiving there's a typing error. Let's say we have 100 plus 75.
That's 175 over 25.
Yes, 25V. So what's our V?
7.
175 over 25. You have what? 7 meter per second. This is the answer in the book?
Yes, that's answer for A.
Okay, 7 meters per second. Because I have to be sure that we know what you are saying. Then, so we should calculate the magnitude of the what? Of the force.
False.
We know that force is M V minus U over what? Over C. So you find the magnitude of the magnitude of the force of what? Impact. So who impacts who? Is this one here that impacted this, right?
Yeah.
So we're going to concentrate on this.
Yes.
So we are having, what is now the mass of, the mass is now what now? The mass is 10. What is the velocity?
10 meter per second.
And what?
7
And this.
meter.
So what time do you use to do that? We have 10, which is plus 7.5 instead of minus now, over what is the time? Time of
5
impact.
seconds.
5 or divide by 5. So this one can cancel this. I'm now having what? 2 brackets. So 3.5. That will give us what? 35 Newton. Is it 35? 35 is the answer?
Yes. Sir.
Okay. So this is the solution to the question.
So we got minus in the textbook minus 35 Newton.
Yes. I got to, ideally supposed to write the V first. Looking first, not V.
Yeah.
And what's the V here?
Minus 7
So
meter per second.
it's supposed to be minus 7.5 minus 10. I just decided to use it as positive.
Yes.
Supposed to be minus 7.5 minus 10.
Yes, sir. I'm done with this.
Wait, keep going from there. Keep going from there.
I'm done.
Okay. So I will stop here. Anyone, just go through the questions. Anyone you can solve, we'll do it in our next class before we enter a different topic or continue with the same thing, all right? So we are going to enter a subtopic. Did they teach you reaction in the lift?
No.
And that's the problem. This is the problem I'm seeing. This is the problem. You are not supposed to teach. You're not supposed to learn this subject, this topic. You're supposed to be learning all these things in SS2. That is why they are not teaching it deep anymore. Because your learning is supposed to stop at either Hooke's law or correct electricity. All you are teaching now is just over zealousness. You're not supposed to learn all these things until you are in SS2. And that's why they are not teaching them deep anymore. So notwithstanding, we'll continue tomorrow.
Okay, sir.
Okay. I mean, in our next class. Okay. All right. Take care.
Thank you, sir.